Alright, so this is 4.4 part 1 notes. So in this section, we're going to be finding the trig functions of any angle. So before, we were finding the trig functions of angles on the unit circle, but now we can do it with any angle. So it says, let theta be an angle in standard position with x, y, a point on the terminal side of theta, and r be equal to this. So this is going to be our formula, how to find r, but it's pretty much the Pythagorean theorem because we can always form a right triangle with the point given, but I'll explain that in a second. And then we also have our trig functions. Sine of theta is equal to y over r, so y would be the y coordinate of our point, and r we would have to find. Cosine is x over r, tangent y over x, cotangent is the reciprocal of it, and then secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. So this is super similar to what we were doing, but before, if you remember, our formulas were y over 1 for sine, or x over 1 for cosine. But that's because we were on the unit circle where our radius was always 1. So here our radius is going to be something different. So instead of just being y over 1, it's y over r, whatever our radius is, this length. So example 1 says, let negative 3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So we have our point. You can always, with the given point, drop down a line to the x-axis. So always you can drop down line to the x-axis, make it a right triangle. And r is always going to be our hypotenuse. So my x, the length of the side of my right triangle along the x-axis was negative 3, which is my x here. The height is 4, because that was my y. And then I can use Pythagorean theorem to find my radius, to find the hypotenuse of this triangle. So that would be 4 squared plus negative 3 squared is equal to r squared. So 16 plus 9 is equal to r squared. So that would mean r is the square root of 25. I did a couple steps at once. So r squared is equal to 25, square root both sides. So r is equal to 5. So our radius is 5. Our x is negative 3 and y is 4. Find it helpful to write them all down. That way it's kind of easier to see what you're plugging in where. So now we want to find our trig functions. So first I'm going to start with sine of theta. So sine is y over r. So that would be 4 over 5. Cosine of theta is x over r. So negative 3 over 5. And tangent is y over x. So 4 over negative 3. So those would be the 3 trig functions that it asks for. We could always find the reciprocal functions too, but here it doesn't ask. So just to reiterate, the first thing we want to find is our radius, r. We could either make a little right triangle, use the Pythagorean theorem to find it, or we could use that formula from the last page. Once we find r, we just plug in x, y, and r into our sine, cosine, and tangent. All right, example 1, we're doing the same thing. We want to find our 6 trig functions. So for a, it gave us a point, 4, 3. So the 4 is my x, 3 is my y. I have to find my radius, r. So I'm going to do Pythagorean theorem. So 4 squared plus 3 squared is equal to r squared. So 16 plus 9 is equal to r squared. So r is the square root of 25, so r is just 5. So now I can plug that in to my trig functions. So sine of theta, sine is y over r, so my y was 3, and r is 5, so 3 over 5. And then the cosecant is the reciprocal of that, so I would just flip it, so it'd be 5 over 3. Next, I need cosine. Cosine is x over r. My x is 4, so 4 over 5. And then secant is the reciprocal of that, so 5 over 4. And then lastly, tangent is y over x. So that would be 3 over 4. And cotangent is the reciprocal of that, so 4 over 3. So it helps to know that sine is y over r and cosine is x over r. But in case you forget, you can always look at your triangle and just use SOHCAHTOA. That would work too. Because my x is 4, my y is 3. This is theta. Sine is opposite over hypotenuse. So opposite would be 3. Hypotenuse is my radius, which we found was 5. So that's just another way of doing it in case you ever forget that sine was y over r, cosine is x over r. You can just make your right triangle and use SOHCAHTOA. Alright, for the next one, so I'm going to drop down my triangle. You always form your triangle with the x-axis. So here's my little right triangle. This side's -8, this side is 15. Because 8 is the x, so that goes along the x-axis. 15 is the y, so that goes up and down, up or down. Now I want to find my r, so I have to use Pythagorean theorem to find r. 15 squared plus -8 squared is equal to r squared. 15 squared is 225, plus -8 squared is 64. So this would be 289. If we take the square root, we get r is equal to 17. So 289 is a perfect square. It's 17 times 17. So now that we have our x, y, and r, we can plug it into all of our trig functions. So sine is y over r. My y was 15, so 15 over 17. The reciprocal function is cosecant. So I just flip it, so it'd be 17 over 15. Next, cosine is x over r. X is -8, so -8 over 17. And then the reciprocal function secant would be 17 over -8. Then we have tangent, which is y over x. So my y is 15 and x was -8. 15 over -8, and cotangent would be the reciprocal, so -8 over 15. All right, example 2, we're doing the same, but it doesn't give us the triangle, which is fine. We can do it without. So -4 is my x, 7 is my y, and then I would just do Pythagorean theorem to find my r. So it'd be -4 squared plus 7 squared is equal to r squared. So 16 plus 49 is equal to r squared. So 65 is equal to r squared. Take the square root. Two factors of 65 are 5 and 13. We don't have any pairs, so we can't simplify. So just leave it as, the square root of 65. So that is our r. So we just plug in x, y, and r into our 6 trig functions. So starting with sine. Sine is y over r. So it'd be 7 over square root 65. Just like before, we have to rationalize. So multiply by the square root of 65 for our numerator and denominator. So we get 7 square root 65 over 65. Next, we have cosine of theta. Actually, before cosine, I'm going to find the reciprocal, so cosecant. So this would be r over y, because we just flipped sine, so that would be square root 65 over 7. Now for cosine, this would be x over r. X is negative 4 over square root 65. We have to rationalize. So negative 4 square root 65 over 65. And then secant is my reciprocal function of cosine. So it'd be r over x, so square root 65 over negative 4. Then we have tangent, which is y over x. My y was 7, so 7 over negative 4. And then cotangent is the reciprocal of that. X over y, which would be negative 4 over 7. So there's my 6 trig functions. For b, I'm going to do the same. This is my x, y. To find r, we use Pythagorean theorem. So 3 squared plus negative 4 squared is equal to r squared. So 9 plus 16 is equal to r squared. So r squared is 25. We would take the square root of both sides. R is 5. So let's plug it in. So sine of theta is y over r. So negative 4 over 5. Its reciprocal, cosecant, would be 5 over negative 4. Cosine theta is x over r. So 3 over 5. Its reciprocal, secant, is 5 over 3. And then tangent is y over x. So negative 4 over 3. And then cotangent is the reciprocal. So 3 over negative 4. Right, so that's it for the notes today. Don't forget to turn in the notes by the end of class, and you guys can start working on the WebAssign. The WebAssign will be due on Wednesday after we do part 1 and part 2.